There it goes. We're live. Zack, welcome back. We had what I thought was an amazing conversation last time around. Let me go ahead and share my screen. We can kind of recap visually just kind of everything that we had gone through. Uh, but yeah, I really appreciate you taking us through stuff last time, going through really laying out for us, you know, everything about bundlers, and we kind of took things into this matrix, I guess, where we're looking at the different generations of bundlers through the time, or through, you know, I guess starting with Grunt and Gulp over here, Babel and Browserify, but then going into Webpack and now into like this more interesting like generation of things that we see here. I think like as we scrolled back down to like where I wanted today's conversation to go, though, I think like one of the biggest questions that got answered last time was just like, what is bundling? And I think this kind of lays that out like decently well. Like bundling is you start with some input format, you have a desired output format, and bundling is how you get there. So as developers, we can work with whatever this input format we want, and we can get to, you know, something that's optimal when it comes to like the artifact we deliver. And yeah, interesting piece about that too is just there's multiple different artifacts, multiple different reasons for the artifacts. Because I think for most of us working in JavaScript, we started out front end. Most of us, this is looking at, well, probably we wanted like ES6 or something like that, but browsers weren't ready for that yet. So we had a bundler step to get us there. But now it's like, well, sometimes we want to be working on our package, but now when we publish it, we want that to go out to NPM. We need to have that in a way that's easily consumable. So that was my main takeaway from our first conversation. Would you agree? Let's maybe start there.
So I would say I think when it comes to like NPM publishing,
Yeah.
it's it's probably not as crucial, though. So the main one would be when it goes from NPM and it goes to the end user. So when it goes to the browser. So I
Right.
think bundling primarily is your last mile concern.
I
Because
see.
I think when we were doing NPM things, like I don't know, I remember back in 2014, 2015, um, it was pretty common for you to just Babel the node modules directory as well.
Yeah.
So I don't even think we really were even considering like using at least more sophisticated build phases in the packaging stage. I think it was mostly focused on like last mile. Now it's more common. I think probably what really made it more common was like the rise of ESM support in
Uh,
Node. And then you really need, okay, now you need more complicated use cases. Back when things were just common JS, I mean, I honestly don't remember bundling much in my packages. Maybe doing a bit of transpilation, but even then, I used to just ship JSX to NPM, and I'd say, cool, like the end user transforms it into their final format.
right.
Um, I would even say though that there is still some. I don't know. It's always a double-edged sword, even today. Like even my own packages for Federation and stuff like that. Um, I really it's sometimes painful to actually bundle those packages because doing so, I'm setting the polyfills or the compatibility stage, which
Mhm.
also I think like probably the big one is like if you're using CommonJS or something as the output, um, then you have all the helpers that SWC might bring in, or you're essentially converting the code into more bloat
Mhm.
that the maybe the last mile doesn't want. But it's become such a big practice of like, oh, well, you don't really transpile your node modules anymore for speed. But the one thing I kind of wish that we had for package size was a more automated way to figure out like, okay, well, what's their browser list targets more specifically, and to be
Mm,
able to output maybe like 6 or 7 different transforms. Say,
right.
all right, if you want just, everything except JSX, here's hypermodern, and it's just not going to have any weird syntax. But currently, it's like, oh, well, then you polyfill it, or you put some transformers and helpers in there so that the user doesn't have to like think about, oh, do I have a polyfill for this, or do I support set, or a spread operator, for example, things like
Right.
that. You still have to consider in your package, but adding a spread operator means you have to convert it into like keys in a loop, which potentially is
Yeah.
not as performant.
Right. Right. Right.
But
So
yeah, so
I guess that some of that comes down to like this idea of input to output. Well, so like one of the things you mentioned was like the spread operator, and like how we would like how could we polyfill that? So some of that is just like as a developer, we would like to use the spread operator sometime, right? But sometimes the output that we're targeting for that just doesn't support that. So yeah,
yeah, or
that's
like the user's output doesn't support it, which is the
mm,
so even if I'm doing my npm package and I ship a
right.
spread operator, that'll break the end user unless because one, there's bundling, but then there's still the transform step. Well, that's all part of bundling, I suppose, under our kind of definition here.
Yeah.
But then you'd have to know, oh, I need to transform the node module as well. So we kind of have to just down level everything. But still,
Yeah,
the
yeah,
whole
yeah.
idea is the code that goes into my IDE is the input format, and the thing that I import, um, you know, upstream or downstream is going to be in a better output format to be consumed. And then finally, the thing that goes to the browser is going to be in the kind of, again, another output format different from what we're writing in.
Yeah, yeah. That makes sense.
I mean,
Well,
think of good examples like TypeScript. That's definitely an input format only.
yeah. Yeah. Well, I mean, with some of isn't like the idea for like Dino and Bun that they just treat that as an output format as well? Or
Well, not
that's
kind
we're
of.
getting into weird different
Like
nuances
I
of
think
it.
we're blurring the like what's going on just a tiny bit. Yeah, the runtime's incorporating it, but really under the hood, even what Node and all of them doing is they just run strip types just in time.
Yeah.
So,
Oh, I see.
which
Well, that makes it
so
easy.
I mean, it definitely makes it easier, but we're still bundling, or not bundling, but we're still transforming it just in time to
Yeah.
convert it back in. What would be nice is if the runtime actually supported typings, and then we could
Right.
have, a whole lot more. That would be really, really nice just in general to have. I think it'd also help with like data marshaling and other things. But
Yeah, for sure.
what we're trying to do is bring that experience a little bit closer. Because also, if you think about, oh, if I just want to write a node script really quick, we do a lot in TypeScript, and it's a really big. It's really frustrating when, oh, but it's a TS file, so the
Yes.
resolve doesn't work, um, or oh, because I have a declare in there, it's going to break the whole thing. Now I need like TS node, or like it adds a lot of friction in there. So I do like that they're trying to make that a bit better.
Yeah. Well, just being able to run natively like a TypeScript
Mm.
file that alone, like you'd think it would be easier. And I think it's getting that way. But like this was something I actually hit recently with one of the packages. We published like a starter package for Advent of Code. So you could just kind of pull that down, work in TypeScript, and just like run these puzzles. Do you do Advent of Code, Zach? Actually,
No, I don't.
you're
Unfortunately,
too
I have
good
no
for it.
time to do these type of things. My advent of code is just like continuing to do what I do in
Your
bundles.
whole
I
year
do
is
that
Advent of Code.
I'd
I bet.
say like 300.
Yeah, that's awesome. Yeah. Well, yeah. So, well, just getting to the point where we're realizing, hey, like, why is this so hard? I feel like Dino released Dino 2 recently, and I saw like some marketing stuff from them that was just like, why are we doing things like this? And like taking that step back and just being like, well, let's just run TypeScript. Um, I don't know. Let's just get back to getting stuff done. That was refreshing. I don't know if in general is taking the right approach, just because I think part of the reason why everyone is going to JavaScript right now is because of npm, like because of all the packages that are available in the wider ecosystem, all of that things. So I think like this idea of, well, how do we work with what we want, but still get to like this desired optimal best place out. I feel like this whole step of bundling has to exist for that, because we can't just start over and say let's figure out a way where these two are the same. I don't think that's a reasonable. I don't think that's just a pragmatic approach to things. But all right, we're getting a little bit off topic. I wanted with this conversation to like kind of like lay a pyramid almost about like what is bundling at the very base of it, which I feel like we kind of did. But then go into like I want to flesh out these stages a little bit more. Like this is just from our last conversation. So I'd love to like maybe as a second layer of the pyramid, Zach, is just like get your thoughts about laying at a high level, like what are the stages, what happens just very broadly in those. And then from there, like once we lay that second layer, that's when I'd love to like get into your code, like the stuff you go on, like you work on every day, your advent of code day 361 or whatever you're on, so we can see like what that looks like, because that piece is actually really interesting to me. I imagine it's like a lot of like transforms, like string manipulation kind of stuff, I would think, but yeah, I'm curious. So
So surprisingly not. The manipulation pice is a big part of it, but that's so much deeper down into the bundler
uh-huh.
that it's not something that, I mean, I would say we probably do that a bit more in the RsPack end, but that's usually because over there we are adding new base level capabilities, which involves actually parsing at its lowest level. But
Right.
like a lot of what since like big areas that I've been working on is like in I work on module federation a lot, and that's quite a elaborate um,
Yes.
feature set. One of the reasons it's been so difficult to bring, in the past to other bundlers is really just lack of API. And the the main reason of that though is because like I don't know, for us to even support Federation, I think when we added it, it was like 50% of Webpack we had to change. And this was, you know, a couple weeks away from releasing Webpack 5, and then I'm like, hey, surprise, new feature, and we had to go back and rewrite about half of Webpack to support it.
Yeah.
So um but in a lot of that, it's APIs, like it's working with module factories, or like how it resolves the what it is that we're doing, or how we're actually manipulating the module graph and things like that. So I'm working on maybe like a step higher than the string manipulation, which is a lot of things like in actually what we kind of call like factorizing the modules. So that's kind of like where you're saying, all right, I have an import. I'm going to resolve that import, and in the process of resolving it, I'm going to create a new module, or a new
Mm,
key in the chunk, which is instead of a chunk is essentially a big object, and it
right.
exports an ID. It's like three named exports: ID, name, and modules. And modules is just a giant object with a bunch of keys, and then every key in there is like the module ID. So React would be, a key inside of the chunk. But the process of getting React into that chunk is the factorize step, where we're saying, okay, we're going to take this, we're going to do a bunch of stuff to it, and then finally, the output of that, or the code generation phase, is what goes in. And so the process of like factorizing it is figuring out, okay, well, what is it? And then what type of module does it become? So Webpack's also been interesting because it's language agnostic. So this is like a big constraint of the other build tools that we've like, worked with, is they're all hard coded to ESM. So there's no
Mm,
real concept of factorization. It's ESM must go in and ESM must go out, because there's no, but in Webpack, we've got when you import CSS, there's a CSS module. When you
right.
import JavaScript, that's referred to as a normal module. And
Okay.
so everything can be trained. Webpack can support anything that you can add a parser to it for. So, like a couple of years ago, I was able to make it compile Java apps like natively. Because all I needed to do was add a new linker and parser that understood Java. Because technically, the bundler has no constraint on language. It's purely
Okay.
doesn't know how to link it and doesn't know how to parse it.
Right.
Um,
Right. So let's can we unpack those two things actually? Maybe that's a good
mhm.
place to start. Is linking and parsing. So what are these two terms? So linking the just on the face of it, this sounds like when you import something, know where to get it. Is that is that right?
Essentially, it's going to be when you
Uh,
import something, know where to get it, but it's also, I think, a bit like know who's using it. So, it's kind of like you know, wh where is it and who uses it and in what order does it need to like be instantiated in.
okay.
So if I have button, okay, well to link button, I need to see well who's using button first because if index is importing it, then I need to first parse index, then I need to go and link uh, uh, fetch button, link button to it. But then if index is, importing other things as well that also use button, then it's also part of, okay, well, we have to make sure that it's linked to everything. And then we can start the evaluation phase. So linking is essentially like
Okay.
connecting the dots. So these things are, where they're connected to. And I would say linking is also a big part of like how tree shaking works. It's kind of like building up the module graph so that we can understand the ins and outs of each kind of connection.
Right. Yeah, that's what it sounds like. It's like you're building the so linking is creating some sort of graph or some sort of map of all the code and how pieces of it depend on each other. So parsing then, what is parsing? Is that like turning the text into like data into a abstract syntax tree, or is that what
Essentially, yeah, it,
okay.
it would be, parsing it is going to be taking the text and normalizing it into something that can be programmatically understood.
Okay.
So, in order for me to do linking, I would first need to know the imports. Okay, but what type of imports are there? Okay, well, there's import from, there's a dynamic import, there's a dynamic import with a variable in it somewhere. There's common JS, there's common JS with like with a require that's got, a variable in it. There's common JS 2, which is just export. There's module exports, there's named exports.
Right.
So all of those things, it's kind of like, okay, well, how do we normalize it so we understand, hey, they're requiring something or they're
Right.
they're requesting some kind of resource or asset. So parsing is largely to understand, what are the parts, what are the variables that are used, what are the ins and outs in a predictable way. And then
Okay.
obviously there's parsing like for Babel and transforming it, but for the extent of the bundler, parsing is mostly focused on global variables. So, if you have window or global this or process env, constants. So for hoisting, modules, hoisting constants like higher up into the bundle,
Okay.
um, imports and exports. Those are kind of the main, and then comments. But that's kind of just for comment parsing is usually just for things like annotations. So like React has like that hash pure comment that it puts on certain things to indicate that it's a pure function. Um,
Oh, okay.
and so a lot of that is so that the bundlers, parsers, there's some standard, well, pseudo standards we have in bundler around, okay, well, we're going to use this pure annotation to, let the build tools know better how to optimize or what is safe to tree shake or not. Um, but those are largely what the bundlers are looking at. It's a subset of kind of what Babel would be looking for. Because
Mhm.
Babel, hey, you want to transform everything. And while you can like Webpack's AST, it's just I think it's ES tree based, but you can or not ES tree, Acorn. There's a few different AST definitions, but Webpack's is I think Acorn or ES tree or something like that. And that AST goes to a loader. So you could take that AST and not actually use Babel and just continue manipulating the AST,
Mhm.
but uh, none of the plugins use that ASD format. So generally, what we end up doing is just doing string to AST conversion. So essentially,
Right.
when you're bundling, almost every bundler that you use, you parse everything twice. There's the bundler parsing it to look for its subset of things, even though it could do everything. And then there's the end user's transformers that parse it again in whatever ecosystem they want, be it SWC,
Okay.
TS, or what's the other one? Or Babel.
Yeah. Okay. So, well, I guess so when we're talking about linking and parsing in this sense, is parsing then the act of like taking text and building the AST, or is this more specific in the way you're thinking about it to this is how we like pull from the text the stuff that we need to do to do the linking to create the graph.
It's to do the linking.
Okay. So parsing is
Because
like the precursor to linking.
yeah,
And
yeah. So in
okay.
order, because think of it this way: in order for the bundler to know anything, we need to convert the text into something that we could iterate over.
Right, right,
So, like, I would need to be able to loop over the imports, the exports, the constants, all the different I/O pieces. What do I need to consume, and what do I need to expose back out at the bottom of the file?
right.
So the very first thing that we do is we start with parsing, and then from parsing we go into resolving, and then from resolving we go into linking.
Okay. So what is resolving? Is that
So resolving, and so this is actually funny. Resolving is one of the slowest pieces of bundler. So in terms
okay.
of builds, like when we were looking at Webpack and okay, yeah, Webpack is slow and we needed a Rust solution to it and all of that. Um, One of the slowest aspects is the resolving phase. And the main reason is to think about like just the mechanics of it. So if you have like a Webpack config, you can, you don't need an extension on the end. So I can just go, require something, and it could be something JS, something TS, TSX, MJS, all these extensions.
Right.
So what the bundler does is that when it parses and it grabs your import, it has to go, okay, one, what's the current path? So
Oh, I
where did
see.
I find the part of linking again? Where did I find where is this asset currently within context of the file system? Now, what are they importing? Now, the parser needs to check what type of request is this? Is this a relative request? Is this an unresolved request, like something that'll be in node modules? Is it a data URI? I have to handle all of those, and then once we get past that, we have to start resolving. We have to resolve actually what it is. So if it's a data URI, there's a resolver for that. If it's HTTP, there's a resolver. If it's file system, there's a resolver. But then without an extension, what it's going to do is it's going to go in order. So it's going to start with JS. All right, didn't find it on the file system for JS at this current path, but then maybe you also have like you know how you can have like the at symbol, like
Yes.
aliases, path aliases. So
Yes.
then it's going to use all the path aliases and then all the module aliases. So it'll start with,
Right.
okay, let me go just from the current directory dot slash JS. Nothing's
Gotcha.
there. Okay, maybe let me go dot dot slash node modules slash whatever JS. All right,
Right.
nothing there. Then let me walk every possible outcome for every extension.
Right.
So you end up doing tons of file system calls to resolve the file because, for one file, you might have to do 10 file system calls to actually find it.
Yeah. So like when
And
we
IO is, again, one of the slowest. IO is the slow part. Like anytime you have to start doing. So we did also something where we rewrote PNPM in Rust, just try and speed up our installs. And so we're like, okay, well, so what impact will it have if it was in Rust?
Mhm.
Turns out, if you rewrite PNPM to Rust, it's only about 30% quicker because the main restriction is either the network or the file system calls.
Right.
So it's not actually, it's not actually the install part, it's resolving and writing. So
Yes.
again,
So
doing imports.
you're still going to be like it's almost like the speed of light is this universal speed limit that we're facing in physics right now. In bundling, we still have the universal speed limit of file IO, and there's just no
Yeah.
way around that. And that makes sense. So resolving is specifically like we see this statement right here. So we're talking about, well, we have to figure out how to resolve this thing right here. So you were saying like we start with I actually don't know what the priority would be, but I guess
Okay,
it would be
so
like you start
do
with like node
in a
modules.
new tab, just
Yeah.
Google Webpack resolve. Yeah, Webpack resolve, and there should be like a an option where
Oh,
you can
neat.
see where you can set like in the configs, and you'll see look for just like dot JS or something, and it should have like a resolve or dot MJS or
.mjs.
yeah, just to see. I mean, just dot MJS. So there should be like there you go. So see,
Yeah.
this is
Okay.
kind of like the resolve extensions. Um, so there's that, and then go
Mm.
down one more. I think there are extensions. So here's kind of the order that Webpack uses, like as an example.
Oh,
So it would
okay.
be, oh, okay, it's going to be JS, JSON, WASM, but
Okay.
it, built into Webpack, it's there's like a few of them, and then like if you look at Next.js or something, it's got uh, TSX, TS, JS, JSX, MJS, MTS, like
Yeah.
all of these orders that it goes in. But
MTSX. Yeah.
yeah, but the user can specify them. But generally, it's kind of you know, if you look in the Webpack docs, you can kind of see like there's some examples of how we start that resolving process, and those are the orders of operation we go in.
Right. So that's interesting. So yeah, I was thinking just with like importing from a package, but not knowing whether that was a package or a like path alias. But we're talking about like even like this could be foo.js, this could be foo.txt, this could be foo.json, I guess. So yeah.
Yeah, exactly. So what we'd have to first do, so luckily what we can do is, okay, well, one, is there an alias? If there's an alias, follow that. And usually the
Mhm.
alias that you're following is going to either be the one, if it's a path alias, then we hit a directory and we need to check, okay, is there a package JSON? Hit the package JSON. Okay, how is it being imported? This comes back to parsing. Was it an
Right.
import statement? If so, resolver should use the exports field. And then again, there's logic for the exports field. And then finally, we'll get to wherever we're going. But in
Right.
this case, it would be, okay, we need to walk all the node module directories recursively. So now
Mhm.
foo, well, if you're in a monorepo, is it foo in this workspace? Is it
Yeah.
foo in the parent one? And
Right.
essentially we have to recurse all the way up to the top of the bundler's context, which is usually like the boundary of the monorepo. And
Right.
we have to walk through every node module and search for foo. Now, if there was a dot slash on here, then it would switch to be, okay, well, now we need to do extension resolution, JSON,
Mm.
MTS, you know, everything, and, until we find a file that matches that fs exists call.
Right, right. That makes sense. Okay. Well, scrolling back out, like uh coming through the process of bundling, we've done our parsing, we've done our resolving, we've done our linking, we were able to create a graph. How do we what comes next after we've done all of this? Is this yeah, at this point, it seems like we have all the data, all the information, all the maybe assets is the right word. They're all understood.
Yeah,
What
so this
happens
essentially gives
next?
us a picture. So this is
Okay.
doing these three steps will give us um, doing these three phases will give us essentially the data structures
Yeah.
required. So now we'll have a module graph. So the whole idea is, okay, I need to build the module graph. Once I've built the module graph, I'm not sure, we'll see in the code where exactly this next part will be, but somewhere in there, there's going to be create the module graph, and then there's going to be actually run the code generation to build that module graph. So, because one is I need to know where all the parts are, and once I find all the parts, then I actually need to run the code generation for it to give me the final asset. So, during code generation is when the loaders will be applied, when all the transforms are going to be applied, when the
Mhm.
filtering and all of that other stuff kind of kicks in. Um, and then finally, you would be getting into chunk creation and asset emission. And then this is kind of where the link phase takes place, if I'm correct. Because
Okay.
first we build a module graph, so it's find all the things that are there just using parser, collect all the stuff without really knowing what it does 100%, and
Mhm.
then once we have the full module graph, then we start doing the linking to it to say, okay, well, this guy uses that
Oh, I
and that
see.
uses this and everything else. Um, so, and then from there, that's when we would go into creating the chunk graph.
I
And then
see. I see.
finally, the chunk graph will yield the assets that are emitted.
Okay. So like creating so parsing and resolving is kind of like these are things we need to create the module graph.
Yeah.
And then linking comes in to play after
Yeah.
this.
Linking comes into play,
Okay.
which will then, yeah, so linking comes into play. And then from there, we would get code generation. And then after code generation, we would be able to create the chunk graph.
Chunk graph. Okay. So this was something we talked about a good amount last time too. Um, what is the difference between chunk, just the phrase chunk, and module?
Yeah, so chunk refers to, so in our case, a chunk is just another type of data structure separate from module.
Okay.
Module would refer to one file. A chunk would refer to things that we're going to put. A chunk is essentially the bundling aspect. So a chunk is a collection of modules. So I
Okay.
need a data structure that defines this is the module, this is what these are the dependencies that it has, this is the parent module of it. Like where does this thing sit in the graph, and like who uses it and who does it need to and who does it need. So dependencies and parents, um, yeah, a bunch of other like random things in there, like okay, like how HMR works. It's all chunk or module oriented. Do I need to rebuild the module? Do I need to invalidate that module? Um, the module also, in part, controls like what exports are used. All of that data is stored on every module, and then a chunk is saying, okay, now we're going to take a whole bunch of modules and put them into one file or one chunk, which is
Okay.
just a collection of modules, and a chunk is again another type of data structure.
Okay. So a chunk is now I think I joggled my mic just a little bit there. Can you hear me again, Zach?
Yeah,
Okay, cool. So a chunk in contrast. So this is an independent data structure. This is actually going to be a collection of modules
hmm
as above, and um, the idea here is when it's outputted, a chunk is one file, is one um,
it's
what's
one JavaScript file that contains a collection of modules, and every module used to be one file as well. So it's just taking files and essentially concatenating them in a way that we can reference them correctly.
okay. So with multiple modules housed, I guess, inside.
Yeah. hmm
So okay, that makes sense. So when we say one file for a module, this is like one, let's say, input file, right?
Yeah. This is
And
like
and
one
so
import. Yeah.
yeah, so a chunk then is one output file.
Yeah.
Okay, that makes sense. Um, cool. A module itself, we have to create the module graph over here because we need to understand all these input files, how they all figure out. We have to figure out how to link them together. We have to create that whole graph. Then once we have that module graph, we can play around with how they get chunked. Is that fair to say, or is
Yeah,
that like
yeah,
some of the work that's
essentially.
being done?
So
Okay.
yeah, and that step is essentially where we get into the seal phase. And so
Okay.
sealing, so it might even be that code generation is after linking, to be honest, because the seal
Yeah.
phase happens. And so for the linker to exist, it would, because in code generation, it would mean, okay, well, what if you have like Babel loaders, and what if they require helpers? So then the linker would have to be underneath. that if I'm right. So I think like linking and code generation, or it might even be a loop where um, cool code
Okay.
generation can yield more things that have to be linked again because maybe a loader adds like React refresh utilities and there's a require statement that's added. So we have to cycle through. Um, there's probably a loop in there where we essentially circle through the phase after transformation to ensure that there's nothing new that we need to relink and reconnect.
Yeah. So it's almost like um so in the between code generation and linking, I don't know why it's doing like this. Oh, it's because silly Excalibur. It's not what I wanted. It's okay. I'm trying to be fancy here. But we essentially there's some linking that could go on between once you get into code generation and linking, you might be doing this a few times
Yeah,
until we can then get to the chunk graph.
yeah,
You mentioned the seal phase. Am I spelling that right?
yeah.
Yeah. Okay, cool. Yeah, apologies for my voice. Excuse me. It is better than last week. So we'll leave it at that. So what is the seal phase, Zach? And where does it
So
come into
this
play?
the sealing phase is really where we get into like the seal phase is the where all the hard work takes place.
Okay.
So essentially, when we seal the build, that means that nothing new can get added to the module graph data structure.
Oh, okay. Okay. So this is
So,
almost like once we're done with this loop, the looping between
mhm.
linking and code generation, here's where we're saying, okay, this is done. We're not going to muck with that anymore. And then and then we can play with the chunk graph. Would that be
Yeah,
the
and
idea?
so
Okay.
then, well, so I think even prior to the chunk graph, because creating chunks is one of the last things that you would do in there. So
Mm,
within the seal phase, there's like a whole subset of like a ton of stuff that goes on. But essentially, this is where now optimization and tree shaking and used exports and all of
okay.
that are created. But sealing means cool, there's no more imports that are going to come along. There's no other things happening in the compilation where a new module might get added. Everything that's going to be transformed, all of that is done. This is the final, this is everything that constitutes your code base. Now we're going to seal it, which essentially means module graph dot freeze, and then we can start iterating on that. And then there's like almost so I would say linking is also almost like two kind of series in here. There's
Mm,
kind of linking it together, figuring out what it does, who goes where, which modules are needed for what. And then there's the another part of the link phase, which is kind of during sealing, where we're saying, okay, now we're going to figure out the dependencies that the chunks go in, all the other parts that kind of take place in the seal. But this is where, things get sorted. So one, do the tree shaking. This is also where chunk creation. So if you use split chunks, this is where split chunks is used. Um, uh, this is where optimized dependencies, optimized modules, all of that stuff is done in the seal phase, which is like the slowest part of the
yeah.
build.
Well, so it sounds like one of the biggest things here is just like you're actually going to call like object dot freeze on the module graph now.
Mhm.
Yeah. Yeah. So that's cool.
More or
So
less, because what you can do is so technically what we'll do is we do because I think we could go like module graph dot seal, which essentially is the same as freeze. But
okay.
then what happens if during this final phase, maybe you have something like needs rebuild or additional dependence or additional additional resources, like there's certain hooks in Webpack where you could say, okay, well, now that I've gotten everything together and I've figured it all out, maybe I need to, from the information I've derived, maybe I need to do something again. So I need to like send it through a second build step. So then you can also unseal the graph, add
Mm,
to it again, and then seal it again. But sealing it just means cool. Now go back into this loop again and start, generating the chunk resources and everything like that. So
gotcha.
I can
So
seal and
there
unseal it, but that essentially means like restart the lower half of the build.
right. Okay. That's interesting. So we could loop on it itself a couple times in here just because there
Mhm.
are optimizations that would require that. But ideally, it sounds like you would get to a point where you have sealed it and you will not unseal it again. Is that, yeah?
Generally,
Okay,
that's
cool.
that's like if you unseal it, it's a plugin unsealing it. So maybe they're doing something like a execute the module tree or something like.
Yeah.
So what's really cool inside of Webpack is there's also like something called execute module, which means that. So here's a really good example. Imagine if you wanted to create like a static site generator or
Okay.
something.
Yeah.
Now, usually we do the bundling and then we take that build and we just loop through it and like spit out the markup from it.
Okay.
But
Yeah.
now, what you could do is you could just call execute module, and what that essentially does is it's like saying require. So you could say, hey, the thing I just transformed, I'm now going to evaluate that, but all the import froms and all the requires are going to work. So
Okay.
then you could actually, so what you could say is, okay, by importing it, it's going to return the SSR'd version. So you could say, okay, I'm going to export home,
Yeah.
but when I import it, you could have something that actually evaluates it so that the result. So this is how mini CSS works actually. So mini CSS, which is how all of our CSS stuff works, what it basically does is it goes, okay, I'm going to take the CSS, I'm going to convert it into a string. I'm going to then parse it and grab, yeah, mini CSS extract. That's it.
Yeah.
There should be a get link in the, yeah, there you go. You can just click through if you wanted to go to it. But essentially, yeah, let's actually just dive into the code really quick because mini
Sure.
CSS is a good example. So go into source, and it should be in, I think it should be in the, yeah, just search for execute module. And yeah, let's look in or yeah, search for string. It'll be in a
Okay.
string of code.
I think we might need to execute. Does it need to index it before this will work? Yeah. There we go. Okay. Um.
Yeah, and then okay, so here we go. So essentially, we'll have like this execute module stuff in here, and then somewhere here, look for something like exports in this file. It'll be something like um, yeah, keep searching. Let's just see. There
That's the
should
only one
be
in this one, unfortunately.
okay. Maybe go to the loader and let's just see, or
Yeah.
yeah,
Where
go
are
to
we
the
right now?
loader. We're
Site.
on the plugin. So mini CSS is a
Okay.
plugin loader combo. And
Gotcha.
look for import module. Yeah, okay. So then there should be a. Is this the only things that have it? There should be one more.
Let me see
Like
what
a.
else we can find here. It's
There
not
we go.
import
Okay.
module. Here we go. Yeah.
This dot import module. So when you use import module, you're actually executing the module path. So what we're doing is we're saying this is the request. So basically, here's a key in the module graph, like the final resource path with it transformed. We
Yeah.
execute it, and then what it returns to us is the exports from it. So by doing this, the loader essentially prepares everything. Click on handle exports.
Right here.
Yep. And now handle exports is actually going to give us, this is how you, when you use CSS modules, like, where it like is styles dot the thing I want.
Yeah.
Um, so this is how it does that. So handle exports, if you scroll down in here, you'll just see it's, got, some random pieces, but there should be a loop in here. Yeah, keep going down. We're just going to go for, yeah, you'll see something that just like stringifies an object or, does something kind of rudimentary like that. Um, Down in here. Okay, original exports. Yeah, so see locals, that's the locally scoped style object that we begin to build. So
What
scroll
line
down a
are you
little,
looking at right now?
201.
Okay. 201. I see.
So
Okay.
so then we're getting into locals, and then scroll down a bit more in here. We start to kind of build this map up, and then
Dependencies. Okay.
yeah, and then essentially we get into our exports here, and it's gotten a little bit more complicated since I had last worked on it, but essentially what we end up doing is, yeah, there we go. If locals 263. I think this is where it kind of starts.
Okay.
Yeah, so then see we kind of yield and we create this module ID or this that's the CSS class that it's creating.
Okay.
And then here on local
Ooh,
string,
I don't like these. Yeah, this is so. What is this? Is this a iterator
so this is
or?
creating that random class name, I believe. So like
Oh, I
when you
see.
have CSS modules and they have that hashed class, that's
Mm,
it creating it if I'm correct.
okay, gotcha.
So then that's how you get like those named, well, one, that's how you get it there. But then you see here we go local string, it's var, stringify locals, and it's the object of local exports
I see.
that we're serializing here. And then you'll see there on export string, it's export identifiers, uh, button as whatever the generation is that they've created.
Mhm.
So essentially here we're just saying, okay, so export default, give me the original kind of CSS or give me one, export the style string, and then two, export a bunch of named exports, which is the CSS module that we want.
I
But
see.
how it did that is it used execute module, which essentially meant transform the CSS, pass it through the CSS loader, from the CSS loader to mini CSS loader, who builds it all up, and then it's going to output a string of code. And then what we're going to do is evaluate that code and then loop over export.default and see, cool, what are the class names that it printed into the file. And
I
from
see.
there, we're going to transform it again and create a new string. So we actually execute the code in order to generate the final code. So it would be the same as saying, like, oh, imagine if you wanted to you had a React component and you wanted to say, well, by importing it, I actually want it to render to string and return me the string of HTML that represents that component.
Yeah, interesting.
And so this is kind of what the module execution flow does, which is really interesting, but it allows you to essentially execute the output of the loader to then influence the output of the thing you're going to actually send back to Webpack.
Yeah, interesting. Well, let me maybe can we take a step back further from this?
Yeah, sure.
Because I think one of the things I'm curious about is I've personally I have worked with and the idea of Webpack plugins. I kind of understand what they are. My understanding though is as we're going through this process that we're laying out here, this sort of line, there are hooks in this, right? Where
Mhm.
a plugin could say, by this plugin being present, it can hook into the fact that we've just entered the seal phase, for example. So because we're in here, run this plugin, and this is essentially what we were looking at here with mini CSS, right? Is this is a
One
plugin?
step of it. Yeah, this is
Okay.
one way to use those hooks in there. But
Mm,
I think a big piece would be like to understand the hooks flow.
mhm.
So what you can do, go to rspack.dev, and in there we should have something like, I think under the compiler API, we did visualize a lot of the, so I think under API,
Excuse me.
um, and then the try the plugin API.
Okay. What's the difference between a loader API and a plugin API?
So loader APIs is about mutating the strings, changing the code that like that's where your Babel loader would go, or this is to do, so
I
loader
see.
API
Okay.
is to do with transforming the current module you're messing around with. The
Okay.
plugin API is more about the compilation or dealing
Okay.
with all the modules or adding assets onto it or runtime modules. Like it's for dealing with this essentially not the code, but the process of encapsulating and preparing that code. So,
Gotcha.
like, that's why mini CSS, there's a loader which says, hey, mini CSS, you're going to get a string of JavaScript that's just a CSS, kind of like file loader. CSS loader reads the CSS thing and essentially just creates a string of text, export default the string of CSS that was in there, and
Mm,
then mini CSS plugin is the one who goes, okay, well, from here, I need to add a dependency to say there's a side effect because the loader doesn't know how to put that into the browser's DOM. So the loader just says, well, here's a string. So it's a loader plugin combo where the loader prepares the data, also adds some meta information to like what it's going to return. And then the plugin can pick that up and adds a runtime module for handling the side effects, and then
Oh,
adds a
cool.
dependency. So it says, hey, when the user, because all you're importing when you use CSS is you're just importing, like if it's locally scoped CSS, you're just importing an object of,
Mhm.
export const button equals x341 button. And that's
Yeah.
all that exists. So there's a side effect dependency added on saying by importing that map, there's going to be the side effect of, hey, inject a link tag with a certain resource into the browser. And that's how we know, oh, you imported that CSS, so we need to inject a file into it. But that's essentially the plugin's responsibility for adding the injection system that does that. And then the loader
Okay.
knows how to communicate with the plugin, but the plugin's the one preparing the side effects, creating the factorize steps to say, hey, this is a new dependency type. This is a new module type. There's now a JavaScript module, and now there's a CSS module and a CSS dependency. And so it's responsible for like creating those graph structures and teaching Webpack new tricks. The loader is
Gotcha.
just responsible for taking your string and converting it into some intermediary format or final format.
Gotcha. Cool. So we wanted to look at the plugin API. Or-
Yeah, and then I think if we it's somewhere I tweeted about it the other day. Let me just go to my Twitter and look it
Sure.
up because we have a thing where we have all the UMLs for all the bundler graphs. Um,
Yeah, it looks like there's not much on the site for this right now.
yeah, I can't remember where we had put it. Let me just look it up under me.
Sure.
Because I just tweeted this the other day.
Nice.
Let me go to Soon. He actually has it, and he's probably got less tweets than I do every day. There we are. Okay, so um, do we have chat in here?
Yeah, there's a private chat you can drop it
Perfect.
in.
I'm gonna dump it in there. I'm gonna give you the English one because I don't think your Chinese is
Yeah, my
is
Chinese was
too.
a bit rusty. Let's just say we need a loader API or loader plugin. I
Facts.
wanted to read that.
Yeah, I know like I think about 80 words in Mandarin. I can't speak it, but I can read it. What I will say
Yeah.
though is it's super efficient format. A nice trick if you ever
Ah,
want your language model to handle more context,
yeah.
take your English text, translate it into Mandarin, and send it to the model. It'll use about 10%, 20% of the token size compared to English, and so you can pack like massive amounts of text
Really?
into it
Yeah.
because each character like represents an entire word. So, a
Right.
very complex concept is two tokens versus
Yeah.
that might be like 5 words to us.
Right. That's interesting. That's kind of cool. Okay. So here's the
So this is an
compiler
overview
hooks.
of like here's the compiler hook. So there's a couple
Gotcha.
different hook places. There's the compiler hooks and then there's the compilation hooks. Now the compilation, this is the thing I kind of wanted to if we do have time, maybe we can open up Webpack's code and just look at the compilation thing because it's
Yeah.
really interesting to see the actual order in there and like, oh, so that's how I do this because it's really fascinating.
Yeah.
But this is essentially how it's doing it. So step one is the compiler. Instantiate a compiler. That's going to do some very broad things like set up the plugins that we're applying, set up the
Okay.
targets, set up certain high level things, and instantiate the configuration. Essentially, when you give it a new Webpack config, it's taking that, turning it into an instance, and then doing anything with code is the compilation. And then the compiler kicks in after the compilation is done, aka the seal phase, and then
Oh.
it does things like output the assets. So the compiler doesn't have a ton of hooks, but the compilation, on the other hand, has most of them because
Okay.
that's the compilation is where all the big stuff happens.
Gotcha. So this is the compiler hooks, compilation hooks. Okay. So this is wow. Okay.
So you can see add entry. This is how an entry point gets added. All the things
Yes.
that need to
Okay.
kick in place for an entry point. Then there's finishing the compilation, which is, that's something you probably see a lot in plugins inside of NX if you've messed around with any plugins deeper in there or you've written a Webpack plugin. Finish compilation or compiler done or after done, those are super common hooks that people tap into. Essentially,
Gotcha.
it's like, hey, when everything is done, so I could maybe analyze some data structures.
That makes sense. So compilation seal. This
Yeah,
looks
here you go,
familiar.
the seal phase.
So trying to make sense of this, but Where's the
Uh,
entry point to this? Is there like a starting node, or it almost
um,
seems like a loop?
there, it would be that one, that top, there, that top, where it says compilation seal. So that's the start, and then the end is over here. So seal is,
Oh, I see.
I mean, it,
Start.
yeah. So that's
Okay.
essentially where we start the seal phase in here, and it's going to be, so we have compiler compile. Um, does the so yeah, I'm sure inside of here you'll probably see seal toward the bottom of this guy,
Okay. So
or that it might.
this is the add entry thing.
Yeah. So every time, every entry point you have in your config is essentially, we just iterate over those and go add entry, add entry, add entry, add entry. So your entry
Gotcha.
points in Webpack is just us looping that object and calling this.
Yes. Cool.
So parse the dependencies, we do all of that, and then we get to callback. And so callback is essentially compiler compile. Then the callback takes place, which is
Mhm.
going to be, which I believe indicates we're done with the like we're done with this phase or something like that. Um,
I
let's
see.
see, create factory. Yeah, okay. Then we get into yeah, compilation compile runs its callbacks. Then we get into the next phase of it, and what we'll do is we'll look at the compilation class, and we'll be able to see the order of operations a little clearer as
Okay.
well, because it's a lot easier in the code, in my opinion.
Yeah.
But visually,
I'm
this
getting a
makes a
little
lot
bit
of sense.
lost. Yeah. I
So,
feel
so
like,
it,
yeah,
the
go
seal
ahead.
phase, so in start is essentially compiler compile. It does all of its stuff. It scans, it gets all the module it does all the parsing, it finds all of that stuff. Then it goes compilation seal, and that's essentially what we've been speaking about. So now we're in
Okay.
the seal step, and then we go into hooks seal, which is now that's what I was referring to when I said, hey, it can seal and unseal. And then this is what all happens in that seal step, which is
Gotcha.
we create our chunk graph. And yeah,
Yep.
when the compilation stops accepting new modules, essentially.
I'm sorry. I'm trying to make it big so people can see it, but as I'm doing it, it's kind of messing where things are showing up on the screen. But yeah. Okay. So called when the compilations. Okay. Cool. Well, that's interesting. So really cool. Just part of the graph here. Let me throw it in the chat so people can look at it themselves too. But yeah, it's you can link to the different pieces here, which is cool. So that's very cool. Or the different hooks, I guess.
Hmm.
If each one of those are that. Yeah, you
Yeah.
mentioned. Do you want to pull this up in like GitHub to look through the code?
Yeah, we can pull it up in GitHub. Yeah, let's pull it up in GitHub. Do you want me
Okay.
to share my screen, or do you want to keep controlling it?
Either way, let's try you doing it
All
for
right,
a bit, and I can ask questions. And we can go
awesome.
from there.
Maybe you can also look correlate it back to the visual diagram, because then I can
Yeah.
show it in here, and then that might help kind of link it to the RsPack's uh, visuals, um,
Right.
that we were looking at in that UML, because then you can actually see where it goes from A to B essentially.
Right.
Um, but in the seal phase, that's where all the magic happens. So I'll start sharing my screen here. Okay, so then inside of here, I'm just going to pull up. So this is the Webpack code. Let me create a bigger font here. Okay, so there's a couple. So before I jump into that, there is one thing that's just a good piece of information. If anybody wants to understand how Webpack works, like, or what is Webpack doing, a
Yeah.
really good place to start, also to just see the arsenal of things, is going to be called the Webpack options apply
Okay.
file. So apply. So basically, what this does is it says when you give a user a config, this is what your config actually means. So you can see, like, if we say, okay, let's say, for example, if they have externals preset to web, boom, externals plugin kicks in, dependency type, URL. If it starts with HTTP or HTTPS or standard, then those are all externals plugin. And if it's externals with modules and it has a URL, then it's a ESM, HTTP import. If we were to say target is node,
Hmm.
options.target. Let's see. So target. So then cool, target node. That would be the node target plugin that gets added on. or if it's
Okay.
Electron, it's the Electron plugin. So basically, all of your configurations are just all we do is take that config and we apply various plugins to it. And every
Okay.
single option, DevTool, source map plugin, every single option that you have adds various plugins to it. This is
Okay.
also one of the, I mean, you can see how massive some of these get here.
Yeah.
Like all of that. Const plugin, that's how it knows how to deal with constants and, do certain things like define plugin where you could like string replace certain values inside of things.
Right.
URL plugins, import meta, every single thing in here, even import plugin. This is also one of the reasons why uh, like everybody's like, oh, okay, Webpack's kind of slow. Or even what we've seen in RsPack is yes, RsPack is faster, but say compared to maybe something like Rolldown currently, we probably anticipate Rolldown will be quicker.
Okay.
But one of the reasons is RsPack is actually very fast. But when you add plugins onto it, that has overhead. So it's this trade-off of amount of power versus the amount of things that it can do. So if we turn off about 60% of the plugins, it'll be 100 times faster, but it'll only do 40% of what, Webpack's capability is. So, but what does that is
Yeah.
essentially options apply. So all of
Right.
this happens in Rust 2, where we're adding this mountain of things. And of
Yeah.
course, the more you add, the more complexities that it kind of tacks on. But you could, also churn these parts off or just use the base compiler class on its own, which doesn't
Yeah.
know how to handle a node output. It just knows the very basics. And
Right.
that thing, again, is like, 100, 150 times faster than RSPack is. But it'll
Yeah.
only do, it'll essentially be like ES build. Like
Yeah.
it'll
So
only
it,
do basic in and out.
gotcha.
Um, anyway,
Cool.
okay, so getting into the compiler.
Well, let me ask about so what you were
Hmm.
trying to demonstrate with the options apply is essentially each option. Well, this is almost like the I don't know the exchange center
Hmm.
of Webpack where it's all plugins. It's just
Yeah,
a matter of how many are we going to bring in and which ones, and that is driven, I guess, essentially by the options. Yeah.
yeah, this is the
So
options
okay.
apply. And so this is also what I meant by like, okay, Webpack is technically two things. I don't know if I said it to you, but I've been on like another podcast and I said it at JS Nation, but
Uh-huh.
there's Webpack, there's, oh, people don't like Webpack. What usually they mean is they don't like the configuration style of Webpack.
Okay.
And then there's the architecture of Webpack. So
Mhm.
to Rust in RsPack, this is a lot easier to delineate. The only thing that makes RsPack Webpack from a user's perspective is this file.
Okay.
Or in our case, we call this the bindings. So this
Right.
is our Rust bindings, or this is the options apply. And this is what connects the user's config to actually making the compiler do its things. So when most
Right.
people say they don't like Webpack, what they mean is they don't like this file. And they don't like that verbose configuration.
Hmm.
But the second piece, hopefully now looking at this, you can see, oh, okay, so the user options and that is a separate thing from the actual architecture. So
Right.
RsPack is two things. One, it has the bindings of Webpack, which means that it has a similar API from a user-facing standpoint.
Right.
Two, it has the architecture of Webpack, which is essentially this highly composable, very, very flexible, scalable internal architecture, which essentially means every single thing is a plugin, and the core is actually, a hand like five files, and then the rest of the code base is plugins you optionally can add onto it. So we
Hmm.
utilize the Webpack architecture in RsPack, which allows us to grow it and make it extremely adaptable in the future.
Right.
As well, it's a very solid, proven architecture.
Yeah.
Then there's
Gotcha.
the plugin API and the bindings that maybe some don't like, some do like. But again, we could change that at any point. Like RsPack
Hmm.
v2, we might just ship a new bindings file and say, okay, well, now, we could have a whole new bundler API if we wanted.
Yeah.
And we still have the reliability backed by the Webpack architecture, which is a totally separate convention from what the user's interfacing with or the plugins the user interfaces with.
Gotcha. So that way you can play. It's kind of maybe like going back to what we had seen before, which was uh we can play with how we want to work with things, how we want to configure it.
Yeah. Yeah.
In the end, it's
Um,
going to like the the transformation inside of that will make it so we can work with that while still getting the best possible performance, the best possible output.
Yeah, yeah, exactly. And this is like cool. This adds all the common practices. Like, hey, if you don't want source maps, you could turn it off, and that would save you several milliseconds. Or you could just
Mhm.
not apply it. I could delete all of this and just pass compiler entry, and here's an output file system. And cool, it'll know how to do that. But if I wanted it to make more than one chunk, I would need to have a chunk format plugin to tell it how to output the chunks. Because it won't know what format to put chunks in. It'll just glue all the files together and say, here you go. So
Right.
you actually need to tell it, oh, here's a data structure for rendering the chunk file.
Yeah.
Otherwise, it doesn't know how to do that because, again, the
Right.
compiler is really, really, really refined and really small, and you can tell it how to render chunks. Not,
Yeah.
it doesn't know how to do that automatically. So it's a really, really cool, like, composed way to do it. But it's also great because people are like, oh, well, how do I find this or how does that work? You can always just open this and see exactly how the sausage is made. And there's a bunch of really cool plugins that you can just go in and utilize yourself, and you could get more
Yeah.
control over it. So I always reference this all the time to be like, so how do they do optimization of some obscure thing? And then I could be
Yeah.
like, oh, okay, maybe it's JSON modules plugin. Cool, there's how they do JSON modules. Awesome. Now I can create something similar if I needed to. So
Gotcha.
a bunch of things that you wouldn't normally see.
Yeah.
So anyway, it's a great reference point. So now getting into the compiler, because
Yes.
this is where we kind of start the journey in here.
Yeah.
So first we have like all the hooks that we get. So you can kind of see we have initialize, should emit, done, after done, additional pass. So additional pass means, hey, I need to rerun this cycle again. I need to re-execute the compilation. Maybe at
Right.
the end of the compilation, I go, okay, I built up the tree like Angular does this. They build up the tree, they see where everything is, and then they are going to use the first pass to influence the second pass and maybe add metadata into the fields or metadata into the modules or other things. So then they do a second pass through it after adding more information or more assets in from kind of using the first pass as a way to crawl, as like a look ahead. So one, run the compilation, do a look ahead. Two, pass through it again with the knowledge of the look ahead you had just done.
Right.
Um, you have, before run. So run is essentially where compiler, starts. It's usually in dev mode.
Hmm.
Emit, hey, this is when it's outputting stuff, and this is the compilations you'll be able to get access to.
Right.
Did assets emit? What file and what info? So every time a file is written out, you will get the asset emit that you can hook into, mutate that, and then finally it will actually pipe it out after it's actually written it. This compilation, the current one, compilation, any compilation happening, like mini CSS. If you wanted to hook into compilation, mini CSS uses like child compiler. So compilation hook would listen to mini CSS, to HTML Webpack plugin, to all of those. This compilation would only listen to the one that your actual main build from your config started. So that's
Okay.
your main code, not when the plugins do additional things on their own.
Gotcha.
Module factories, blah, blah, blah. We have before compile. Then we have like the compilation. Then you've got the make hook. So essentially, finish make is the last point before compilation begins.
Hmm.
So you have all of this where you can do things, and then the finish make is essentially I'm done making the compiler.
Yeah.
So if you wanted to do something async, I wanted to say, hey, before like the compiler takes flight, I might want to like go in here and maybe verify something on the file system or wait for something else to finish or call an API or do something async.
Yeah.
The
Yeah. Yeah.
l- the last play the latest point you can do that in the build is going to be in finish
Finish
make.
make. Okay.
After that, it then starts running it actually begins to do the compilation step, and then module will start getting added and so on.
Okay.
So this is like the last point I could say, hey, let me configure plugins or do things to it before actually beginning to process the user code, is in the make hooks.
Gotcha.
Um, then you obviously have, watch, run, read record, shut down, nothing too fancy, but you can see it's not a whole lot of elaborate things. After plugins is really useful because this is like, okay, well, once all the plugins of options apply have been added, um, And maybe once like the user plugins have been added, then you could say after plugins to say like, hey, after all the normal plugins are done, add something to the end of it. Because maybe you need to read some options, or maybe the other plugins have a make hook as well, or something like that. So this kind of lets you tap into it at the end of the phase, which is kind of useful. That's how federation works. It uses after plugins to then add the federation parts on.
Oh,
Um,
okay.
so then, we get into some basic options we set up on the compiler. And so all of this things, this is what you would get
Hmm.
when you go like compiler, dot options or whatever when you're inside of a plugin. Like
Hmm.
this is what all of these are. It's these guys. Like I could go compiler dot running and I could check if it's running, like inside of my own plugin and so on. So anyway, so then let's go down
So
into where
that
we
so
actually,
so
yeah,
this is kind of what we were seeing, where there is a compiler API for like
yeah.
this is essentially like how we well that's the class we're looking at, right?
Yeah,
Is
this is the compiler
okay,
class. So this is the big one. This is what takes your config, creates a new compiler from it, and takes all your plugins. Just puts them on there. Maybe starts to
right.
calls the apply hooks of them. So now if
Okay,
your ones have all of those, this is what does all of that.
gotcha.
And
Okay.
then where we actually get into the compilation phase is really like when we start a new compilation. Then we go this hooks compilation call, or this hooks compilation, which there's two records here for it, but uh, essentially you'll see how we actually
Oh,
hide
okay. I
this
see. I
one
see.
in the
So
future.
so when we're constructing the class, this is where we're applying all the different hooks, all the different things. When we call them inside the class methods, here what you were showing there was essentially one of those hooks getting called. Yeah.
Yeah, yeah,
Okay.
exactly. So
Makes
call,
sense.
there's call and then there's tap. So users tap it, authors call it.
Oh,
So when
interesting.
I call this, then how I would do it is, and then whatever params it gives me, which is usually and or params because that's what it gives. So then that's how
Mhm.
a plugin would utilize it, and this is how the compiler would call the tap.
I see. Okay.
So then this is where we get to it. So compiler.compile. Now we're starting to actually heat it up. Boom. Step one: create the compilation params. Hooks before compile, call async.
Okay.
This hooks
Yeah.
compile, anything the user wants to add to the compilation params.
Right.
Then, boom, new compilation. So we create compilation. And then now, boom, see, we're gone.
Yeah.
Compilation, suddenly we disappear. And then what we have is this hooks make, finish make, return the
Yeah.
callback. Then, uh, and then finally we get to the uh, after compile and we actually execute the callback. So then in here, what we're going to do is, okay, we have make, compilation finish,
Mhm.
and then compilation seal, and then compilation after compile,
Right.
and then there's the callback. And then that's the end of the compile step. So you can see
Cool.
finish make is the last point where I can start to manipulate the compilation or I can make changes. I can screw around with what plugins are applied or what options are kind of going on in there. And then
Mhm.
the very next thing that happens on the next tick is going to be compilation finish, which is essentially now, okay, when compilation gives me, then compilation will give me the finish hook when
Mhm.
it's done. And then, then we actually kickstart the whole process and say, okay, well, now on compilation finish, seal it,
Yeah.
after compile, and then finally return the callback to the bundler itself, and then we're done. So, and then, close, shut down. So this is kind of like where the meat starts, is in the compile step.
Yeah.
And all of this is, we have like create child compiler. So for example, how does this compilation work? Um, and you saw, oh, but this compilation and compilation, they were both in that create new compiler.
Mhm.
So this is actually how that gets separated. Child compiler has new compiler that we create. We inherit options from the current class.
Right.
All the plugins are reapplied. So this is a big thing. I don't know if we see it in here. It probably is in the compilation. Oh yeah, here. See, all the plugins are reapplied. So we say, hey, get me the plugins that are
Right.
on the root compiler, and then we map over them and we call apply again on them. So that's how your
Mm.
plugins get reapplied to the child compiler, and that's why a child compiler can't have totally different plugins. You can add more, but you can't remove
Yeah.
because it's actually part of the it's technically a slice that can, well, like I can't say create a child compiler that outputs common JS when I'm building web
Oh, I
because
see.
we already have set up we're inheriting off of the compiler and just saying okay reapply these, but it's the same thing, just a variant of it where you could mutate it in other ways or add different loaders, but the plugins are essentially all copied across the instances.
Mm.
So then, how we differentiate a child compiler from the main compiler, you'll see really the big thing here is in the hooks. These are the hooks that are not copied. So what we do is
Oh,
we
I
just
see.
go through all the hooks and we filter those off, and then we filter them out of the taps. And then the child compiler, call, child compiler, all of that, and it starts.
Oh, I
So
see.
this
So
compilation
like
would
this
only apply
compilation,
to the top
yes,
level,
that's what
but
you had mentioned
compilation
before.
won't be filtered. So
Right.
compilation is called on when I create compiler, it's called on both
Mm.
because, hey, this compilation is also a compilation, but
Right.
any child compiler filters the this compilation hook off, so they will never tap it. So that way it's only your user config and your
Right.
user intended stuff that ends up getting this compilation. You won't tap mini CSS doing its thing.
Yeah. Cool.
So that's
So,
kind of, a bit of how the
yeah.
sausage is kind of made in here. So
Well,
then the kind
I
of
think one of the big things to take away from that is just like, so you had mentioned sort of like a solid architecture to what is going on with Webpack. Is at this point, are we looking at the core of Webpack? Like you mentioned,
Yeah,
there's
so
like
this is
five
the
files.
this is we're in Webpack's
Okay.
core repo and we are
Yeah.
in the compiler class. Like this is
Cool.
the heart
So this
of
is this is actual Webpack. This is not
yeah,
the plugins. And most of Webpack is most of what I think of. I think when I
yeah,
think of
yeah.
Webpack
Most
is
of
the plugins.
Webpack's is plugins. Like so
Yes.
all of this is just like, there's a handful of classes here, but even
Mhm.
like export info, that's a plugin. So how what exports are coming off of something,
Yeah.
that's export dependency plating. That's getting
Right.
the members. So call parser handler, parser
It's
hooks, call
it's
member chain.
yeah, it definitely appears to me like most of the, let's call it like implementation of the work is being done in the plugins, whereas the core piece, like what we're looking at, the compiler, this is essentially a skeleton, which
Yes.
is I think what you keep alluding to is like it is a well architectured skeleton. What people don't like when they say they don't like Webpack is maybe the things that get attached to that skeleton in some ways, but the skeleton is sufficient for, we were talking about gens one
Yeah.
through five. This is a
Mhm.
sufficient skeleton for the next
Yeah.
several, the next several generations, at least, it
Usually,
sounds like.
usually what people are saying they don't like is they don't like this.
Okay. Yeah.
They like the RS build solution where, hey, it's just plug and react and, maybe
Yes.
source
Mhm.
entry, nothing fancy. I don't need to worry about loader chains, or I just want to say, hey, I want like how Vite does it. Like that's what
Yes.
users prefer these days, less verbose. They don't really care about a lot of this stuff. Maybe
So
once in a
yeah,
while they do, but they don't want to have to configure it just for it to work.
yeah. So as not so looking at this is what people don't want. What they do want is like the very nice v.config.js file. That's just like
Yeah,
maybe a
yeah,
few things, if that. And
yeah, exactly. They like it more streamlined, but now there's also
yeah.
a split here. So this is something Vite did very, very well. They changed the game in this, which was streamlining user configuration, making it easy and understandable for
Mm,
users to implement things. And this is something we took note on when we created RS build was all
mm,
right, but there's it's a double-edged sword because users want simplicity, framework authors don't mind simplicity, but they need robustness. So
mm,
how do you target both markets where you need like example is like Vercel,
mm.
Next.js. There's a reason Next.js is so great. Arguably speaking, I know there's probably opinions around this, but if we're talking about this, like you know a SSR framework that has all the bells and whistles that practically works under every circumstance.
Mhm.
Um, the reason that that works so well is because Next.js is the world's biggest, most complex Webpack plugin. That's all it
Yeah.
is. And but you see, that's the thing. So yes, while users might not enjoy the verbosity of a compiler or of something like Webpack, this is like you need the horsepower for things like Next.js to exist. The
Yeah.
problem that we had, up to Gen 4 has been too much verbosity. There was no split between, well, maybe 80% of the users don't need all of this. So we need two facades for it. We need the author facade and we need the
Mhm.
user facade. So
Right.
aka RsPack versus RsBuild. If you want to use RsPack, start with RsBuild. 99% of the time you don't need RsPack.
Right.
Anything you want to do with RsPack, you can access through RsBuild. But RsBuild creates a very Vite-like style of configuration that's easy to extend and much less verbose.
Yeah. So would it be fair to say that like what Feet did was provide a opinionated approach where the opinions made sense? Um,
I would say,
or
like, really, what they did, and this was in part, like, I think part of the challenge was it was a forcing function that Vite had to exist. Because I think what
Mhm.
Evan's original goal was for Vite was not necessary. I can't really speak to his
Sure.
full intentions. I'm just spitballing here, so I might be
Yeah.
wrong. But I think potentially one of the reasons that Vite came along was things were too slow. This was what, 2019, 2020-ish, but things
Mhm.
were too slow. He needed a solution to make it quicker. Uh, ES build was not sufficient. Rollup was not sufficiently
Mhm.
fast. So he had the idea of, well, what if we glue two build engines together? Okay, well, if we do that, we need to make it not, literal hell to work with.
Right.
Thus, we need a no, we need a build tool that can handle the mechanics of dealing with the build engines under the hood and provide something that, is simple. Since
Yeah.
both Rollup and ES Build don't have large APIs, Vite inherently ended up with a more streamlined API as well as some extra orchestrating stuff because they are outside of the bundler. They can prepare ahead of time and then call the bundler and do whatever. So it just
Yeah.
created a really nice design flow on, okay, this is simple but effective, and all the complexity is now hidden under the hood. But I think part of Vite's main objective was to deal with the complexity of the fact that they needed two different build engines in order to do it.
Right. So
Now with
I'm
with the roll down coming out, Veet kind of almost changes what it is. Before it's kind of like a wrapper plus other cool stuff that they've added on. But
yeah.
now a large portion of it, at least when it first started, a large portion was to just deal with the mess of dealing with rollup and ES build and trying to normalize the chaos of these two different phases. But now with roll down, it's going to be okay. Well, all of that can just be its Rust bindings.
Right. So like when you said Feet changed the game when it came in, that's kind of what we're looking at here. If you can see my screen again, Zach, I'm sharing mine.
Oh
But
yeah, my bad.
this is from our last conversation. Was just like what Feet did to change the game. Like you said, brought in ES build and rollup, and it's pretty much like a wrapper on top of that, but it's a wrapper with a like this interface. Like you're working with Vite right now. You're not working with rollup and ES build, but you are working with Vite, and so that it sounds like that is what people liked. Is like they like this interface. It doesn't matter to them so much what is behind it, right? As long as it works, that's enough for most people to be happy. So when we can go look like forward to the next gen, like you said, with roll down coming in, more performant, Veet can still exist with it being like and now just a wrapper on top of roll down, but it can maintain its
All the
like
mess
the
is gone for them, or a large
yes,
portion of this. I don't like. I'm saying this as respectfully as I can, but like the slop, and the slop isn't their fault.
right,
It was a like there's been some complaints around some aspects of Veet, like, oh, the inconsistency with production and development and blah blah blah. But yeah, but that's because you're using two different build tools, and both build tools are, unfortunately flawed.
Right.
But this is kind of what roll down is going to attempt to do. Instead of having to deal with you know, Veet was limited by the fact that it didn't own the bundler. So it could only be as strong as its underlying tools, and those
Right.
underlying tools were very resistant to change.
Yeah.
Now, when they control their own future, a lot of the gripes of it kind of go away, and it's more going to come down to, I don't know, it's probably preference nowadays. Like in the Rust ecosystem, it's going to be, well, what do you need it to do, and like, what do you prefer doing it with?
Right. Right. That's cool. Well,
Which is a
it'll
better
be
place to
very,
be in.
yeah. Well, it'll be interesting to see like just how that develops. Is so like the team that built Vite. So that's Evan Yu, same guy that did like Vue, right? Is he working on Roll Down now? Is that part of what they're
So yeah,
doing, or is
so
that some
actually,
other
so
team?
so Roll Down was so originally the authors of Roll Down were at ByteDance,
Mhm.
and they were
And
on
that's where you
the
work, right? So
yeah, yeah.
cool.
So I think Roll Down, ByteDance had nothing to do with it. I just want to be very clear on that. Like, it's just a cool bit of, past info.
Yeah.
The authors of Roll Down had been working on building a roll up, basically like similar issues to, oh, well, what if the build just had better CommonJS support and better HMR?
Mm.
And that's something that neither ESBuild or Rollup have. ESBuild has good common JS. Rollup is the SM only. ESBuild is too inaccessible and doesn't have any HMR. So each one had their own flaws. And so I think at one point, as a side project, he was exploring this roll down concept.
Yeah.
Eventually, like they ended up working under the RsPack team for a while, and then a couple of our team members kind of transitioned over to Veet when Veet kind of took roll down to be the kind of future, which I'm super
Okay.
happy for the author, and while it sucked to lose some of our team members. Um, like again, I couldn't be bitter about it at all. Like it's the best thing that could have happened to the dude had a project and it was definitely not getting the cred that it needed because we're obviously very webpack oriented and have really really weird complex build needs.
Mhm.
So the fact that it got picked up by one of the big up and coming tools, you
Yeah.
know congrats and kudos to him because it really, and then Evan came in and now it's really kind of they've taken it and he's got some more resources and they kind of are now pushing it over to get all the other bits and pieces kind of tied up. I think now probably trying to get more, I'm not sure I haven't really followed it since back when he worked at ByteDance, but
Right.
essentially he built it on his own, found a good use case for it, got kind of acquired under there, and it's all under kind of the Veet umbrella or maybe the Void Zero type thing. I'm not sure what their structure quite looks
Yeah.
like, but
So Void
you
Zero is the name of the company they founded. They've got funding for that now to like I think what they called it was build the future of the web, which sounds really cool. And they're off to a good start with Feet for sure. But yeah, okay, so
So
cool.
there's
So
been some like, oh, well, isn't because like the way that the language was specified was like, oh, well, isn't this just another Rome tools kind of thing? And like that was what I had when I first read it as well. Is I'm like, oh, I've read this before,
yeah, yeah.
but the big missing formula that nobody else who attempted this didn't have, like this was the thing they didn't have, was they
Mhm.
didn't already have a ecosystem. So I
Yes.
think this is where, okay, yeah, maybe some of the language sounds the same, but the
Well,
variables are different here. You've got
yeah.
a 7 million a week install base off the
Mhm.
bat. You're not saying, hey, here's something brand new with new APIs that everybody must figure it out. You've already got a big following and a big user base around it. So I'm very interested to see how it pans
Well,
out for them.
yeah. Well, I think you have something else that Rome didn't have, and that is like a proof of success in Vercel using Next as like I don't know their business model that well. I'm obviously not with them, but it seems to me like Next was able to like propel Vercel into like a very good place, a very profitable place, a place where a lot of people want to invest and want to be in. So like not saying Void Zero has to follow that model, but
Hopefully they
this
don't
proof,
follow it exactly, because
yeah,
I think they've got a lot of good cred with the community.
mhm,
And I know Vercel is sometimes controversial about these things, but essentially they have proof of success. Hey, this is
yeah,
something that
exactly,
already is actively used. It's not a novel concept. It's getting rid of the pieces that were holding back the Vite ecosystem. Plus, I'm guessing maybe some enterprise capabilities that help step into what larger organizations might require. Like that might be the other facet of Void Zero. I'm not
Yeah.
too sure.
Yeah. Well, it'll be interesting to see what happens for sure.
For
But
sure, for
yeah,
sure. It'll
but
be a
cool.
worthy competitor either way.
Yeah. Well, that's really cool just to see. It seems like the competition in the space is really driving a lot of stuff. Especially
Yeah.
for for RsPack and RS build. That's something, at NX we've been very interested in paying a lot of attention. And we've had Column on before. We've had Lois on Module Federation in particular. Fits hand in glove with what we're doing at NX with like mono repos, and it really gets down to like when we're looking at the sort of import format to outboard format. I don't think we're there where you can just like do whatever and you can arrive at module federation, but it's pretty close and it's converging on that, where it's like, yes, you have to run like some generators. These config have to be there because we need to know like how module federation kind of fits together, how some of these things will work. But I feel like we're converging on this, where we will get to a point where you just write your application how
Yeah,
you want
you
to
could
write it.
infer. This is very similar to how
Yeah,
Zephyr does it, where they kind of infer everything. You just tell us, like, almost like, what are your externals? And then they can
right.
go, oh, well, since we are piped into your CI, we know all the versions that are available. We know what this thing's going to vend. So
Yeah.
all we need to know is what comes from where, or you don't even need that up to an extent. You could just scan all the imports and know, oh, well, this the name of this app. If you have like a Federation config file, you could
Yes.
say, oh, well, if
Yes.
there's any import that meets that name, then those are the remotes and automatically configure everything for the user. I think we could have gone this route because when I had first designed Federation, I actually designed it to use comments. So you would have
Mm.
magic comments that you would place in the files and it would automatically figure it all out. So it was very, you know,
Yeah.
magic.
Yeah.
But Tobias was actually the one who kind of assisted in the design that we use today, which was a double opt in, very explicit uh, uh, one, and I think the main reason really was is because, well, one, Webpack's just one tool, so it's not going to have this omniscient, you know, organization-wide perspective,
Right.
and it was about keeping it safe. Like you don't want to suddenly have React coming from somewhere else if you didn't opt into that rule.
Right.
Um, and so those were some of the concerns around why we make it less magic. Like you have to, we force you to put steps in there to make sure you're
Yeah.
aware of the side effects your app has.
Right. Well, so module federation seems like, well, to me at least, I'm not super uh involved with it aside from the conversations that we've had here. But it does seem to me like it's almost a very similar thing to what we were talking about with Webpack, where if you can create sort of like the skeleton and say, well, here's the different ways we can do that. You can, like you said, you can have the magic comments, or you have like the very explicit config, the opt-in config. Once by doing that, you are kind of building what could be a skeleton for some framework to come along then and say, we will manage like how to put together that skeleton as long as you do X, Y, and Z, or build your application in this way. Or even better, in my opinion, just build your application like you normally would, drop in, some plugin at the end, some plugin into your bundler, maybe. It seems like that's kind of what Zephyr's trying to do. But
Yeah,
it's building
Zephyr is
like actual
essentially
deployment
just like
into
a
that.
yeah, Zephyr is essentially like an encapsulation of the Module Federation plugin
Hmm.
plus, so it's Module Federation V2 plus a runtime plugin plus a data structure that they output, and then
Hmm.
part of the Zephyr plugin is like asset emit hook. So as assets are emitted to the compiler, they're emitted to the cloud infrastructure directly. So
Right.
we can actually, we can write directly to the CDN prior to it even going to your file system itself. But if you can capture all of that, you have all the data, you have that explicit control just through integration. Therefore, you don't introduce the risk aspect because you have, again, something aware beyond the scope of this one instance. And that's something, obviously, it's really hard to just do in a compiler safely because the compiler doesn't know anything beyond its compilation context. But this
Mhm.
is where something additional comes in because also now, well, because it's async, you have this kind of middleware that can communicate back and forward. So Federation at runtime can ask the API, hey, I'm this app at this version, what should I be doing? And it can say, you should be using React from this guy. And it'll go, okay, cool, I'll do that.
Yeah.
But, so it's the perfect kind of division of labor, I think. Like, you don't want the tool to make too many decisions because either that means you're stuck with whatever I kind of cook up, or I think also I just like the separation of concern. So a big
Yeah.
thing for me in general is like I really wanted Zephyr to exist, and I'm like one of the founders of it, but yeah, I have a lot of reservations about being an open source and then starting a startup and then monetizing the open source. Um, so the I do kind of like how it's structured here, where I basically focus heavily on Zephyr Cloud. That'll be it. I heavily focus on the open source federation mechanics. It's basically, what do we need it to do at ByteDance? What does VMock do? How do I pull the features of VMock out and put them into federation? What Zephyr is doing is VMock and Zephyr are kind of based off of the same forked repo, which was my old Medusa project.
Right.
So
Right.
internally, the code is very similar, like the same function signatures. Um, but the core architecture was the same, and essentially, like my what I primarily focus on is I need Federation to support VMock and support the needs of ByteDance. By doing
Mhm.
that, because the architecture of Zephyr happens to be similar, because they're the ones who actually owned the Medusa project originally,
Mhm.
that means that like it creates a nice separation of concern where one, I don't want to bubble up all the things into this master solution that I cook up
Right.
because it also has too much ease to corrupt the open source,
Mhm.
whereas I'm kind of like, okay, cool, I literally only work on the federation parts and I support the needs of ByteDance, which has a proprietary VMock engine, but because our goal is to say as much of VMock should be open sourced,
Yeah.
that means the runtime needs to support the enterprise business, and that also means that Zephyr just needs to create a similar management layer. But we already know that they're compatible because they are both based off of the same core from,
Yeah. Yeah.
back
Yeah.
when me and like Jack Harrington kind of started messing around with a dashboard of some kind.
Right.
So it creates a really good control structure where the one doesn't influence the other, and
Mhm.
that the tech that stays in between is still privately owned by just me.
Mhm.
And uh, and like it's a separate funnel that it's cool. That is something that the tech must support, but the tech is ultimately has one focus, and that
Mhm.
is to support the loading in a flexible way for large use cases. Luckily,
Right.
ByteDance happens to have a use case very similar to Zephyr, so it creates a very organic, uh, you know, benefit without me having to, you know, like be concerned with like outside pressures or influences on the health of keeping it truly open, truly free, and no, oh, but it only works with A, B, and C.
Right.
If
Right.
you want
Right.
to recreate the infra, it can work, but some parts just require like 10 people working for a year solid to create. Unfortunately,
Yeah.
like NX, similar kind of constraint.
Right. 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 That makes sense. Well, cool. Well,
All right,
okay.
so
I
we
do
haven't
want
gotten to the
to.
compiler thing, but I
Yeah.
wanted to know, do you want to just go through the seal phase? Because that's really where the only interesting part is. And it's just
Yeah.
the hook flow. So it's like 40 lines of code,
Right.
but it
Let's take
would
a
be
look at
cool to.
that.
All right.
I do want to just like at the top level. This is
Mhm.
not satisfying to me, this dangling arrow, but I think from here, like once the chunk graph is all put together, we're pretty much just looking at file IO at this point,
Yeah,
right? Like writing it.
exactly.
Okay.
And so
Let me
this is
draw that. Like
this is
just
where we get to the chunk graph creation as well, so you can actually see what goes on.
files. So we're pretty much like writing the files out. So chunks, each chunk gets a JavaScript file, chunk.js files, and then you get like an HTML file, like a
Yeah, yeah. That
index.
technically that's like a side effect of another plugin, but yeah, you get
Sure.
the outputs that come from somewhere else. And
Yeah.
then inside a chunk graph, there's also like optimized chunks and stuff like that. But we could just simplify it as that's all part of the final creation. Because the main thing is sealing the build, tree shaking the modules, and then it's split the chunks up however we
Yeah.
want them to be split, um, and then just dump those files out.
Cool.
And then in there you could go like an optimized chunk or after optimized chunk, or
Hmm.
there's a few other like random hooks in there, but essentially the main thing is the chunk graph and doing any final loops over it, like a Terser plugin that's applied at the optimized chunks hook.
Yeah.
Um, but the tree shaking stuff is technically applied up higher, but that's not necessarily terser. That's more Webpack eliminating export keys and export dependency fields off of sets and maps so that the links are just missing, and then terser can come in and it just rips out, then it goes, oh, well, this variable is never referenced in the map, therefore I can delete that part. And that's how the dead code elimination works, which is a
Yeah.
bit separate from tree shaking.
Yeah. Cool.
Tree shaking
All right.
yields the dead code that then the optimizer eliminates. That's a good way to put it.
Yeah,
Like
that makes
there's
sense.
no var exporting out to it, so it just removes it.
Yeah, yeah, yeah. So yeah, that makes sense. Do you want to show? Let's go through the seal phase, then
Yeah,
let's look to wrap up because I probably
yeah,
need to have a hard stop in about 10 minutes.
yeah.
So
We can do it. We can do it, and then
cool.
so all right. So very quickly in here, so we have the unseal, and this is essentially what unsealing does.
Uh-huh.
Chunks clears the chunk set again, clears the name chunks, clears the groups, clears the entry points, resets the assets, and then, module graph unfreeze and removes all module attributes. So that's how you restart the seal phase, essentially.
Yes. Okay. Let me ask you real quick on just line 2909. So hooks unseal.call. So we're calling the unseal hook at that point.
Yeah.
And so the way things hook in is that blocking, or I think we saw most of those were asynchronous.
This one is blocking. So this one,
Okay.
well, actually, we could go and see. Oh, wait, that's actually in here. Unseal is a sync hook.
Okay.
So this is a blocking hook. Lots of the hooks are blocking. Finish
Yeah.
modules is the
I mean
async
that
series,
it would make sense
but
for them to be blocking based on
yeah,
like a hook system. So that's cool.
yeah,
Okay. Makes
yeah,
sense.
exactly. So it's because the hooks also are ordered. Like I might need to
Yeah.
wait for unsealing to finish before I can start sealing again, for instance,
Right.
or after chunks. So, some things you need to wait in the order of operations, but the unseal will also help us view why we have some of these like this.
Yeah.
Um, let's just seal hook. All right, so seal, we have a callback. So sealing is async, I believe, because it provides a callback.
Hmm.
Um, Or no, it's not. It's okay. Well, see, the process of sealing is async, but the seal hook is not. If that makes sense. There's no there's no await. So
Right. Right.
to the compile because this whole step, there may be async phases somewhere inside of here,
Hmm.
but in general, the hook itself is not. So all right, so the first thing that we do is we say, cool, callback. So we get the final callback, which is just saying, all right, factorize, build, like essentially the clear all the queues. We're now done with the process. Then the first thing we do in Seal is we create a chunk graph.
Okay.
So we pass the module graph into it, and we pass the hashing function. And then from there, we go, okay, call the seal. No, nothing new is going to be added. Then we get into a while loop of optimized dependencies. So this is where now you can start to do all sorts of fancy stuff. So if you just do a global search in here, you will see that there's probably .tap. So here you can see flag dependency usage plugin. It uses optimized dependencies tap. And now this is where, exported module info to map. And now it shows me which modules and dependencies are used. That's a plugin. Flag
Yeah.
all the modules as used. This is how sharing works with Federation. So when you mark something as shared, it has used in unknown ways, which is
Yeah.
set
Yeah. Yeah.
by flag all modules as used. And then you have, another one which is side effects plugin. So all three of
Right.
those are examples of optimizing the dependencies. These are tree shaking. These are bits and pieces like that.
Right.
Um, And then you would have after optimized dependencies. It was just like, hey, when the optimization is done, I don't think we use this anywhere. So this is mostly user plugins. Maybe you want to do something after it's done moving things around. You need to like move something back. Then
Right.
users could get in here knowing all the internal removing of exports and doing whatever is done. So then we freeze the module graph.
Okay.
So now we've sealed the module graph and it's put into the cache, and we have before chunks. Freeze the module graph. Now you can no longer change exports, do any kind of tree shakes, or all the link pieces. All of that is done,
Yes.
and
So
now
we're
we're going to
we're
lock.
freezing it. We're locking into place so we can now make our chunks. Is that
Yes.
okay?
So
Cool.
this means that like somewhere like halfway through creating a chunk, I can't add something to the module graph.
Right. Right. Right.
Like you can, it'll just not. It just won't show up because it's been frozen. So in
Right.
order to do that, if you were to say, oh, well, halfway through the chunk, I'm going to read something, and then I want to update the module graph, you would have to go, okay, collect the information, unseal, make your, go back into optimized dependencies, and then
Yeah. Yeah. Yeah.
seal it again, or whatever to kind of restart it.
Yeah. So
Um,
it's almost like, oh, what's the word for this? I'm reaching for like a word from my computer
like
science days.
mutex
A
or whatever.
mutex.
It's like
Yeah.
almost like thread safe, but not
Yes.
using multiple threads. But it's a
Right. Right.
similar
Right.
kind of
But
concept.
instead, it's this object that's out there, and we're freezing it just to be like, well, this is holy right now. Like, hold
Yeah.
on, let us chunk it, then we
Yeah,
can
and even
we can
module
play with it again
graph,
later, but wait till it
exactly.
gets
And even like
unsealed.
module graph, it's just a kind of big data structure, the module
Mhm,
map metadata. But even the freeze thing here, it's not just object freeze, but it's essentially put it into a tuple map and
mhm.
store it on the cache, and then unfreeze it, and that just tears it off the cache again. Um,
Gotcha.
so anyway, so then this is where it kind of gets cool. Like I learned a lot in this stuff, especially working in Federation. This is kind of the area that I play in a good bit.
Yeah.
So then we're going to go, okay, loop over the entries. So these are kind of your entry points. The things that you add to your entry points, those are strings and key values. The compiler reads all of those, calls add entry, which adds entries to a map. So
Right.
then this is the entry point, this will be the entry point. This will be this. So entry point extends a chunk group. So these are your entries that get
Okay.
added on. And so this is essentially like the memory representation of your entry point. The
Yeah.
dependencies that it has, what's included, and the options, like just
So
very high level.
yeah, yeah. So what makes an entry point like a special chunk? Is this just like it has a main, or is this like this
Y-
is
So the entry
yeah.
point, what makes it special is typically it's the one that will require the Webpack runtime and export the library export back out. So
Oh,
chunks,
okay.
you can't just like if this was ESM world, you can't just go and ESM a random chunk
Yeah,
because
yeah.
all it's going to do is give you like a module, like a set of module graphs. The entry
Right.
point is the one that says load the Webpack runtime if it's not already in line.
Right.
Then Webpack require the module ID I want, which may or may not be in this chunk or some other chunk. And then
Right.
once I have that, return the export back out and essentially pull it out of the Webpack runtimes module thing from whatever chunk it's in and
Yeah.
return that to the end user. Like in Federation, it's a var.
Yeah, that
So
makes
it would be,
sense.
app1 equals Webpack require Webpack container entry
Yeah.
app1, which
So
is
so
a
like
somewhere in there.
so an entry point chunk is almost one that is enough to be viable by itself. If is that
Yes.
maybe that
Yeah.
okay.
It's something that can start on its own and
Okay.
run,
Okay. That
and
makes
can be
sense.
importable
Right.
technically. Um, so then basically we say, okay, so again, up to this point, all of this is just data structures in the compiler. There's no chunk concept yet. So this has
Right.
just been, okay, we have a bunch of entries, let's add entry, and all that's doing is it's creating new data structures, more in module graph, more in, other things, and we're just building up a big, ginormous module graph. And then
Right.
finally, we're going to go, okay, well, the entries is what started the process. That's where our crawlers begin. That's where all the module, we start linking based on who uses what and where and blah, blah, blah. Then we go, okay, well, now that I have the data structure, let's begin sealing it and outputting it. So we loop over all the entries and we go chunk, add chunk name. So if you have entry main or, entry point main home, whatever, take the key, the name of your entry point and add chunk with that name.
Yeah.
Then now we start adding all the chunks. Hey, if there's a file name that we want to use for the chunk, boom, get it
Mhm.
off the file name on the entry point or off the compiler options.
Right.
Um, then new entry point and options, so we then take the options from the entry module and we actually yield the entry
Mhm.
point, which is just another thing in the module. It's now a chunk group essentially,
Right.
so these are now
Okay.
clusters of chunks, similar to how split chunks works. And then we can say, hey, entry point, set the runtime chunk if it has like a separate runtime chunk. Entry
Right.
point, set entry point chunk. Now we're saying, hey, this chunk is an entry point.
Yes.
So, hey, entry point, here's your entry point chunk, because entry point's a data structure, it's a group. So here's the entry point chunk to this chunk group per se.
Mhm.
Um, we add a couple other things, just there, push chunk groups in if they exist. Connect chunk and what is it? Connect chunk group and chunk. This is essentially just adding a group to the chunk. It's nothing too fancy. And then in here we go, okay, we have all of our entry modules, we create a set for them. We get any dependency, like global dependencies, which is a whole nother thing, as well as the
Right.
dependency graph of each entry point. So on
Right.
there, this
Right.
would
Right.
be like a giant nested array of, everything you import. So if
Yeah.
React
Yeah.
is there,
Yeah.
this would be React to React
This is
DOM
all
to
making sense now. So, and this was all done in the linking step. Yeah. So,
yeah, and so this is kind of where we're getting to that linker, and now we go,
ah,
okay, loop over all the global ones. So if you have like
right.
add include or some polyfill, that just means, hey, global entry, so a whole bunch of modules will be blanketed into everybody, plus the dependencies actually imported in index.js or button or app or page.js or whatever your entry points are.
Yeah.
Entry point, add origin. So we say, hey, here's where you're coming from. So this dependency requests origin is the entry point. So the entry point
Mm,
start tracking, the linking begins in here.
right.
Module graph, get module. We're going to then use the dependencies to find the
Yep.
modules.
Yep.
Then chunk graph, connect chunk and entry module. So now here's the chunk and here's the entry point. So this is how we set that entry point. Like you were saying before, what's the difference between a chunk and an entry point? This
Yes.
guy. So
Yes.
any chunk could be an entry point if you said connect chunk and entry point module. That would
Right.
mean, hey, it should return a require at the bottom of some kind, or
Yeah.
this
Yeah.
should be the thing that it does in its like run in its startup. This is the thing that it's going to do. This is the thing it'll require. Entry modules, we add, the modules as we're collecting them, blah, 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 module list, and we assign some depths, which is, some other random things. We
Mhm.
get into like mapping and sorting stuff, which is really just, sorting module identifiers so that they look pretty. Same with the included ones. We go through a bunch of random stuff that doesn't really matter. Then we get
Right.
into like runtime chunks. So this is like when you have runtime chunks single, or like in your entry point, when you say depend on, maybe you depend on the vendor entry point, and
Right.
then maybe they have two runtimes. So this would be responsible for now figuring out, okay, what runtime chunks do we need? Is there an API runtime? Is there an RSC runtime separate from a browser runtime? Like Next.js server builds has an API runtime and a server runtime and a server RSC runtime. It's all one build, but the entry points go to a different Webpack runtime, so they can create separate little graphs. So that's how we kind of do that. Is we go, okay, so on the entry point, so like on your entry point, you could say, entry, or it would be something like, import, and you could say index.js, and then you could say maybe it depend on, like Next uses this, so let's just use next example. Depend on, and then they would have, hey, it depends on underscore app. So that's how page works. It depends on underscore app.
Right.
And then runtime would be, Webpack runtime if it's the browser, or if this was an API route, it would be API, and this would be like like a next world, API pages, API index, depend on maybe document, and then the runtime would be API, which could be separate from another one that might have a runtime of page. So you end up with two
Right.
Webpack chunks, and they each have different um, entries and chunks that belong to them. So this is kind of where that generation takes place.
Yeah.
Um,
Makes
and
sense.
then, so yeah, so then basically we have our depend on stuff here. Okay, cool. Through our entries, so we go through here, we get the entry point chunk actually for it. So again, re-referencing the chunk that we get just off the named map. If it has depend on, we do some other things like, hey, get all reference chunks. So if if page depends on underscore at from next, we will say, hey, get all reference chunks for it, and then through
Right.
depend on, list the entry points, get all of their references, and essentially build up what it depends on, and find their runtime chunks, whatever, and ensure everybody's kind of set and configured correctly to create all the
Yeah. Yeah.
top level things.
Yeah.
Um, so then, else if it's a runtime, then okay, cool. If we're going into uh, runtime, then all right, something else. We get the name chunk, get the runtime chunk, which is where the Webpack runtime actually exists,
Mhm.
and essentially go through, get the entry point, set the entry there, to some other random things if it has it. Nothing too, essentially just sorting out runtime chunks and adding them to the right groups.
Right.
Build chunk graph. So this is where we actually begin building the chunk graph. Again, we haven't written anything out. We've now created the top level data structure.
Mhm.
Here's entry points. You have page, home, main, whatever. So those are four data structures. We've now created the graphs for all of them, or the top level ones. So here, okay, we need a runtime chunk for these two and a runtime chunk for these three. And there are three entry point chunks that we have created in the data structure.
Mhm.
Then we actually build the graph itself, which is just a utility that, it doesn't really do much. It just kind of loops over and merges all the runtimes together to see, oh, well, if everybody depends on this, or, uh, vendor chunk is used in both the API and the browser, or API and the server Webpack
Right.
runtime chunks. Then it would say, hey, chunks, merge these two together so that the chunk belongs to two runtimes.
Right.
Um, then finally we say, okay, after chunks. So again, this isn't outputting the chunks. This is, we've created the structure of the chunks. Here's the preliminary chunks with nothing like too
Yeah.
big on it.
Well, you can
Um,
see from the logger the different, I guess,
yeah.
stages that we're
Hmm.
all in. So create
Yeah.
chunks is done at that point, and then
Yeah.
we're into like an optimized step, and that has its own
Yes.
hook. It looks like.
So then a good thing to look would be like, let's look at split chunks plugin, because this is always a nice one to check out. So
Yeah.
where does split chunks tap into? So it goes on optimize chunks. And so here's what split chunks
Okay.
plugin is doing. So it's a big monster, but it's essentially taking your Webpack config that you give us. And
Uh-huh.
what we're doing is we loop through here, run a bunch of regexes, and then it's just adding things to the group. Chunk
Okay.
group, add existing chunk name. Does the chunk already exist? And then we essentially just loop over the modules inside each chunk group, and we push them. We add the module from the module graph, compilation modules, loop over all the modules, pull the requests, and then sort them into the chunk groups they belong into. And we start pushing modules into each data structure. If you're splitting it, that's where the vendor chunk would come in. Oh, well, now if there's
Yeah.
a vendor's one, does a name already exist? If not, create the name. And
Yeah.
then add modules to chunks info map, and we build up the structure, minimum chunks. All of that is all done in here, which is just us looping over the entire module tree in the compilation and sorting them according to who they belong to. Um,
Right.
so on and so forth. So that all happens in the optimize step. So
Right.
we get through here, we get into optimize. We start with optimize modules. This is where, yeah, so nobody actually uses that. But this is usually where you could do like things where you want to tweak how the module works and stuff like
Yeah.
that.
Let
Mostly
me
for
ask
user
you
stuff.
this real
Hmm.
quick. Well, like I've seen this several times. It's like a wall loop with empty. Um,
Yeah.
what's the point of that?
So essentially, what's happening is we create the while loop because you could have multiple. Because I believe so if we just look at optimized modules here, it's a sync bail hook, and if we look at this one, it's a sync bail hook. So it essentially means like there could be multiple of these in here, and basically
Okay.
just it's like
So
so I
we
don't need to
are
do anything
iterating
with them.
through it.
Yeah,
Okay.
I'm
Yeah.
iterating through it, but I don't need to do anything with the iterator. So it's just
Right.
cool. Keep
I
looping
see.
through until
Okay.
there's no more hooks to call,
Until
or they're
this
all
returns
done.
false. Yeah.
Yeah,
Until it says
yeah,
fail. Okay. Got it.
yeah, until it yields essentially. So this just
Yeah.
lets whoever's tapping it from wherever, we'll just run it forever until it's done. Um,
Gotcha.
then after optimized modules, we don't do anything with this as far as I'm aware. Uh, yeah, no, only Progress plugin uses that. So that's like
Right.
after module optimization is done, then you get into optimizing the chunks. And you'll see in here, like, okay, so this is some of my code that I've added, but aggressive merging plugin, limit chunk count plugin, minimum chunk size, remove empty chunks, remove parent modules plugin, like all these things to kind of clean up what's left over. Because now what we've done is we've said, okay, I'm optimizing all the chunks.
Mm,
So potentially I'm saying, okay, so here's a good example. In Hoist, so this is one I just added to Webpack,
cool.
like to its actual core. So if we just look up this optimized chunk again, there should be a hoist container references. So there's a bug in Webpack due to how the runtime chunks are designed, because they're added like at the end almost, and they're not
Right.
really a real chunk. So they're always empty. There's no modules in them. They're blank entry points. So what I do is in here is I go, okay, once Webpack sorts all its stuff out, then I go, okay, optimize chunks. And then what I'm doing is I go hoist the modules in chunks. So when you do your code splitting, you might move your shared module, you might move your shared module into a different chunk. So now it'll
Right.
break React because like shared React is already chunked. And if you move it somewhere else, it kind of breaks federation, which is why
Right.
you can't do split chunks all. So this guy fixes that because kind of what I do is I say, all right, let me hoist all the modules in the chunk. So then after you're done with your stuff, I hook in at the last phase, so stage advance plus one. So after everything internally in Webpack's done, then
Mm,
I loop through. Essentially, I just kind of loop through the chunk graphs and I search for all the referenced modules of like initial modules or external ones or a couple other things. And I essentially just call connect chunk and module. And I say, hey, move this to the runtime chunk. So if it's like, so if it's the federation container code, which is external, that usually only goes to the entry point. But when it's runtime chunk single, only if that entry point's on the page will the remote initialize, which means when the other entry point gets there, the remotes aren't initialized and federation breaks. So what
right.
actually needs to happen is all of those modules need to hoist into the Webpack runtime so the runtime can initialize the remotes all in one go. So how I go through there and do that is I say, okay, well, after this, go and collect them, get them by certain names, blah, blah, blah. And then I find the runtime chunks and I essentially just say connect chunk and module and I move it into the runtime and out of your entry point, followed
Uh-huh.
by cleanup chunks, where I just say, hey, if there's no more chunks in the module, disconnect the chunk from the graph, delete it, and if it's a named one, remove it as well. And this makes
That
sure that you
makes
don't
sense.
just emit an empty file.
Right. Right.
Um,
Right.
so this is how we like actually clean it out. So, this is kind of where all that stuff happens. Merge duplicate chunks. Oh, if they all have the same thing, disconnect this one from the graph so that it updates all the runtimes and all the references so they don't render that they need this other duplicate chunk or this
Right.
empty file.
So
Um,
so let me switch to my screen real quick because this is
yeah.
kind of like what we had talked about where these things might go in on each other a few times where we
Hmm.
have the chunk graph, that optimization, the optimized chunks, that looks like sort of this kind of looping done almost. Is it more like this
Yeah,
almost?
yeah, it can essentially be that where you optimization could cause a reseal or
Yeah.
essentially,
No,
yeah, the
not
optimization,
necessarily
yeah,
a reseal though. It could
yeah,
just be that it could be that we're going to like the seal phase where we're changing something on the module graph, or it could be something as simple as, well,
back
we're just
onto
going to,
itself. Yeah,
yeah, this is only dealing with the chunks. We actually don't need the module graph. Let's just optimize something in the
yeah.
chunks themselves. That's a valid like course for this
Yeah,
to go as
and,
well.
and
So
these loops, this is essentially what you're seeing with the whiles, because that's kind of what those whiles are
yeah,
doing. They're
okay.
just going back on each other, on each other, on each other again and
That
again.
makes
And
sense.
seal itself could also be a full while as well. Um, but yeah, so basically that's kind of how we get in there. From there, we go to optimize
Yeah.
chunk modules, which is like okay,
Switching back to
inside
your
the
screen
chunk.
now.
All
Yeah,
right.
so we can see you.
So the final steps are okay, after optimize modules, optimize chunks, that's where code splitting takes place, split chunks, merge duplicate chunks, hoist container references, all the good stuff around chunking your stuff up the way you want it is done here.
Right.
After optimize chunks, nothing really happens there internally. Optimize tree, which I'm not actually sure what optimize tree does. Just gonna see if I see anything in here. Yeah,
Yeah.
so optimized tree we don't use internally for anything. Um, but it's essentially saying, here's all the chunks and here's all the modules. So if you want to change anything in that final step, like here's both parts together.
Right.
Um, and then from there, okay, after optimize tree, then we get into optimizing the chunk modules, so the things that are actually in there. And this is mostly cool. Here are the chunk, here are the module. And then it would be things like, okay, revive modules before module IDs. So now generating the module IDs that are rendered into the chunk. Is it going to be called node modules React index.js, or is it going to be called 321?
Okay.
Or, so like what's the IDs of that? Is it
Yeah,
named
yeah, yeah.
IDs? Is it deterministic? Is it hashed? And then again, optimize the module ID, hash the module ID, you do whatever, find in the compilation an open ID that we can use, so on and so forth.
Yeah.
Revive the chunks again
Okay.
after recording them. Um, Before chunk IDs, now we can generate the chunk IDs,
Chunk
optimize
IDs.
them. Do you want hash chunk IDs for cache busting? Do you want numeric like in production? Do you want named chunk IDs like in development?
Yeah.
Um, all of that. Then finally, assign runtime identifiers. Look at the names of the runtimes that you would given us, if there were function calls or whatever.
Yeah.
Pass in the entry names, whatever your code is, to assign the IDs to them. Sort items with chunk IDs, nothing too fancy, and then just record modules and record chunks. Um, Optimize the code generation phase, which is not even sure who uses that. Mangle exports plugin. So here's an example. All right, now we're mangling exports. We're actually starting the optimization of the code in there. So then
Okay.
that is cool. The modules that we have, now we're going to generate the code that goes into the chunk. So a lot of this has been, give me everything that I've got, give me a data structure of all the modules that are needed, give me a data structure of all the chunks that are needed. And
Yeah.
now we're going to actually start mangling the source of those things together and taking them and starting to actually go through and do that. And then we create our hashes. And then finally, code generation phase, which is now where process the runtime requirements. So now, if you use Federation and Federation needs module, then we need to do that. Do you need default import interrupt? Do you need to load scripts in here? Add the script loading thing. Is this ESM? Add that. Do you use split chunks? Add the file system loaders, or add chunk loading things. Like all those mechanics is essentially where we process this in the overall code generation phase. Part for creating the runtime, and I think part for actually generating the resources that go that are yielded into the chunks themselves. And then finally, like run all the code generation jobs. This is just an async hook that does all the final stuff. We can look up something that just has it. Code generation. So you can see like a context module, code generation, source type, JavaScript, and then a bunch of things that they kind of add. External module uses code generation. So if
Yeah.
it's an asset, then that. If it's JavaScript, raw source, module exports, stringify the request. If it's CSS, their runtime requirements, data, sources, all of these kind of things happen in code generation. See, look, there you go, source string. Like there's function templating code, like
Right.
strings, const or var. So
Right.
this is kind of where code generation is taking place. And then finally, what we're going to get into now is process the assets. Now we're starting to actually cool the assets. We're finalizing them. This is where we get to. Uh, I can mutate the text of the final asset before it gets put on the file system. This is where
Mm.
you can go and process that. If you do something like need additional seal, this unseal, reseal. So in process assets, that's where you could say, oh, well, here's everything that I've created. Now, before I actually write it to the file system, is there anything you need from like the very end of the build structure? You know everything, you know all the chunks, you know where everything is, how it all works, what all the exports are used. Now you have a hook. Hey, do you need an additional seal? If
Yeah.
so, you can then call that and it will restart the process again. But now you have the entire you have everything except the files ready. And
Right.
then you could start the sealing phase again if you needed to
Mm.
through that hook. Then finally, like should generate chunk assets. So cool, creating the chunk assets. This is now where we start writing them to disk. And that's essentially the final set. Before chunk assets, then this create chunk assets. And wait until we get to the last asset to create, and then we're done with the callback. And now all the files should be sitting on your disk.
Cool.
And
And
yeah, rendering your manifests and all of that. But this is all
right.
essentially doing that. Create the files, hooks, chunk asset, call, and that's where we're starting to write to disk.
Yeah, yeah, yeah.
cache, asset, store, blah, blah, blah.
Yeah. I'm switching back to my screen real quick because I
Yep.
think that closes the loop on
Yep.
everything, right?
Pretty
So
much.
we did it. That was awesome. Exactly. That really appreciate you coming on and like just helping us through all this. I feel like I've learned a lot of just about like taking what I had as just like a black box of like this is something I take for granted and just understanding that a lot more. So that's really cool. I really appreciate
The
the work y'all have done
the
on this. So
No, no problem. Thank you for having me on here. I love that. I'd love to have that visual that we've kind of created out because that's really awesome
yeah,
to have on hand. Um, and I think like so one of the cool things in here, yes, it's a black box, but it's a very predictable black box. Like it's
yes,
not, oh my God, where is it? It's okay, yeah, there's lots of steps, but it's just about, well, what's the step that I
yeah,
want to do the thing in? And then
yeah,
usually the workload in the step is really small. Like, oh, if you just want to remove some exports from, oh, maybe in the client build, you like in Remix, if you wanted to get rid
yeah,
of like it exports the server loader and like the client stuff, and you want to go, oh well, I don't want to send that to the browser. It would be, oh well, you just need to get into the hook into that optimized one. You could go, okay, there's that export info, and you could just say like set remove loader, and then
right,
it's gone from the final generation, and
right.
you could. So it's not super intimidating once
Well,
you drill into the hooks. But as a whole, it's like, okay, well, how do I even get to that hook is the challenging part,
yeah.
which is
I
why I
think
really wanted us to walk through that so you could actually see, oh, so I would tap A and then tap B, and then there we go.
yeah, yeah, yeah. I think one of the takeaways here too is it's actually a very logical black box. And it's one where when you have like the kind of expertise that you have in it, or someone who's worked in that area for a long time, it is easy. It's not as intimidating as it would seem to be able to make adjustments, optimizations, do these kinds of things that can enable some really cool stuff. So
The I would say the what the biggest constraint really is so it's not super hard to do, it's the navigation. So
yeah.
if you know how to navigate it, which is why I really like going through, I always try to like take anyone through the compiler and the compilation class, because
Mhm.
once you go through those and you see, oh, so that's where the hook is,
Yeah.
now you've got about 40% of the navigation sorted. You know how to
Yeah.
kind of go down to where you need to get to.
Yeah.
And
Yeah.
from
Yeah.
there, it's just clicking, Command F like I do. Oh,
Yeah.
okay, so aggressive chunk merging does it. Perfect. I know how to do my own chunk optimization if I want, or
Yep.
custom split chunks.
Yeah, that whole
But
the whole
yeah,
architecture I felt like of Webpack, I understand much better just from going through that compilation class and going through those methods inside there, especially seal, which I think that was
yeah,
another big
Seal's
takeaway.
the
Is like,
big one. That's where all the magic happens.
yeah,
Everything prior to that is mostly like, oh, create some factories or create new dependency templates or set some requirements. It's more just, okay, get the module and pack the module with what does this module need? Oh, if it's common JS, it might need extra runtime requirements for interpreting that. So it's more of the nuanced stuff, but the sealing phase is like the slowest part of the build because that's also where all the good stuff really happens.
right. Well, that's awesome. Well, let's wrap it up there because I've got a hard stop. You've been with us for like 2 hours and change. So, but
Well,
and that
thank you
doesn't
for
include last
entertaining it
week.
for
Well, thank you for coming on for it. Uh, I'll talk to you after the stream. Love to just like take a lot of the knowledge that we've gotten here and put it into something like so people don't have to listen to 4 hours to get all the takeaways because that I feel like everything we've talked about here has been really awesome. So thanks though
yeah,
for
for
joining.
sure.
Let's
Thank
wrap
you
it up
so much for
there.
having me. This
You
has
got
been
it, man.
great.
This is awesome. All right, end of stream. See y'all later.